Good day. In this presentation, we will be discussing the topic of understanding first sets in compiler design. This will serve as a formal introduction to predictive parsing. Let us begin with a formal introduction to the concept of first sets, which are a fundamental component in the field of compiler design. Let us proceed by defining first sets. The core definition states that first of X comprises all terminal symbols that can potentially initiate strings derived from a given grammar symbol, X. These initial symbols represent the very first tokens expected in any sequence that X can generate through its derivations. Furthermore, regarding epsilon inclusion, if a symbol X has the capability to derive an empty string, represented as epsilon or epsilon, then epsilon must be explicitly included in its first set. Now, we will review the rules for computing first sets. The first is the terminal rule. If the grammar symbol X is a terminal, its first set, or first of X, contains only that specific terminal. Second is epsilon derivation for a non-terminal X. If it can derive the empty string, epsilon, then epsilon is added to first of X. Next, the initial production rule states that for any production A derives X1, X2, and so on, all non-silent symbols from first of X1 are included in first of A. Finally, the chain production rule applies if X1 can derive epsilon. In that case, non-epsilon symbols from first of X2 are added to first of A. This continues for each subsequent Xi until one cannot derive epsilon or until all derive epsilon, at which point epsilon is added to first of A. To clarify these concepts, let us examine an illustrative example. Consider the grammar rules A derives C, DC derives A or epsilon, and D derives B. First, we determine the component first sets. The first of C is the set containing A and epsilon, because C can derive either A or the empty string. The first of D is the set containing B, as D only derives B. Then, to derive the first of A from the production A derives CD, we add the elements of first of C, excluding epsilon, which is the set containing A. Since C can derive epsilon, we also add the elements from first of D, which is B. Therefore, the first of A is the set containing A and B. Let us now discuss the practical applications of this concept. First sets are a fundamental tool in the design of predictive parsers, as they guide the parser's decisions on which production to use. They enable parsers to predict the next expected input symbol based on the current non-terminal and the available productions. This is particularly critical for LL1 parsers. Indeed, these sets are essential for constructing LL1 parsers, ensuring that grammar rules can be unambiguously chosen using only one look-ahead token. In conclusion, the significance of first sets is clear. They are not merely a theoretical exercise but a cornerstone of modern compiler theory.